All right, hello, and thank you for joining us. Welcome to this presentation, which is part of an ongoing webinar series, Goose webinar series, exploring aspects of global sustained ocean observing. My name is Albert Fisher. I'm the director of the Global Ocean Observing System Program Office, which is headquartered at the Intergovernmental Oceanographic Commission of UNESCO here in Paris. For the next hour, we'll start with an approximately 30-minute presentation from Lars Boehme. Lars is based at the University of St Andrews in Scotland in the UK, and he's also chair of the Eurogoose task team for animal-borne instruments. He's involved in a large range of international and interdisciplinary programs using animal-borne instruments. After Lars's presentation, we'll conduct a question and answer session using the question window. The question window is open right now. When you ask your question, please click the Send to All button so that everyone can see the queue of questions. I'll be moderating and asking the questions verbally. And the question window is already open now, so if you'd like to ask clarifying questions during the presentation, please go ahead. The session is being recorded, and the video will be put on our YouTube channel, while you'll also be able to find all of our past webinars. So Lars, it's my pleasure to turn it over to you for the presentation.
Thank you very much. I hope you can hear me well. Thank you very much for inviting me and giving me the chance to talk to you in this webinar. It's on animal-borne instruments, and there are so many people working within that field in different topics that I will try to mention them. I think I stopped downloading logos after I had about 80, so I will try to show them when it's appropriate. On this slide, I put the one from University of St Andrews because this is where I sit. And as being the chair of the task team, I put the Eurogoose logo on there. So it's about the history and integration of animal-borne instruments into a sustained ocean observing system. And the outline will be like this. So I will, at the beginning, talk about what are animal-borne instruments, just so that everybody gets on the same level. I think after more than 10 years providing data, most people know what these are. Talk about the animal-borne instruments and how they already provided data for oceanographers. Also a little bit on the biological data that's collected. Then I talk briefly about how animal-borne instruments fit into Goose, really. Do we have current networks? Where are the networks? And obviously, really important, talk about data management. What's done to this data? Is it available? And briefly at the end, talk about what at least I think is the future of animal-borne instruments in a sustained global ocean observing system. So what are animal-borne instruments? Well, animal tagging and marine animal tagging started many years ago. I think the first kind of tag was a pressure gauge on a harpoon to measure the dive depth of a fin whale. And then early 60s, Gerald Koyman put a kitchen timer on and a pressure gauge on a weather seal to get a time depth profile. So it's quite a long history of tagging animals and trying to get information about where they go, how deep they dive, what's their behavior. So that's all not a new thing. And also very early on, these tags included environmental sensors because the biologist wanted to know how these animals utilize the environment, ecology. More recently, some of these tags are built really to provide oceanographic data. So that's one real purpose of these tags, to provide data that's useful to oceanographers. And at the bottom of the slide here, you see a couple of these tags. There are many different manufacturers that build these tags. There are also some groups within universities that build tags that provide this kind of data. This is a slide showing how they look like. So there's a really diverse range of these tags, from archival tags on the left on humpback whales. I don't know if you see my little mouse here, to tags on seals. Seals are really nice animals to be tagged because they come ashore, you can catch them and then they go out to sea. But you can also tag other animals like seabirds, sharks, and turtles. And all these animals will go out to sea, and these tags can provide information about their behavior, but also environmental information. So there are like 3 categories I want to highlight that are really, really useful for an ocean observing system. The first ones are very small archival tags. They are very, very, there's a tiny picture, 2-3 centimeters. They get their position through geolocation, so looking at light levels depending on time. They can have a little Argos PTT, so you get locations provided by the Argos system. And some of them also have GPS receivers, so they record their GPS locations. The data is archived very often, so you have to catch these animals again to get the data back. Sensors on these tags typically are temperature, light, pressure. So you know where they are from the light data, and with temperature and pressure, you can get temperature profiles from the ocean, and obviously you get tracking data and can use that to look at movement and behavior of these animals. These tags need comprehensive delayed mode quality control. Because of the sensor size, the energy constraints, tags include sensors that are often not very accurate and often not calibrated. However, if you provide a good quality control mechanism, they can provide really interesting data beyond the biological data. And the 2 figures to the right, in the middle and the bottom, show an example where people tagged shearwaters, birds that travel from the north of the Pacific Ocean to the south. And along the track, these tags recorded sea surface temperature data because these animals, these birds, sit on the water or dive into the water. And at the bottom, with latitude, you see the change of sea surface temperature going across the tropics from one polar region to the other. So this is already quite useful data, especially in regions where there's nothing else available. Then we have something what I would call medium-sized tags. They are a little bit bigger. Again, positioning is done through geolocation, Argos, or GPS. The data is archived, so again, you have to get these animals back and retrieve the tag to collect the data. But they can also have, because the size is a little bit bigger, have something to provide telemetry. So a way to provide data without the animal, being caught again. And this can be done through VHF radio, Argos satellite system, or mobile phone technology. And the sensors here are a little bit more sophisticated. A lot of these tags can record temperature, salinity, light level data, fluorescence, oxygen. I think there were also a couple of tags measuring other environmental parameters, and obviously pressure if you want to have a depth profile. Again, these tags, mainly driven by biological projects, are often not calibrated and need delayed mode quality control. And because it's mainly driven by getting environmental data to link that to the behavior of the animals, the data is often not provided as vertical profiles, but as what we call time depth recording. So you have a profile of time and depth, and each point has a temperature or salinity measurement. So very similar to glider data, I think, if you're an oceanographer. But again, a lot of people would like to have vertical profiles. And then more recently, like in the last 10 years, different manufacturers started to build tags that are really built to provide oceanographic data. So here the positioning is mainly done through the Argos satellite system, or these tags record GPS information, because you need a better accuracy than geolocations to link your measurements to the environment. Again, these tags can archive the data, so you collect the tag back and download the data, or you can use telemetry to get the data in hopefully real time. Sensors again include temperature, salinity, fluorescence, oxygen, pressure, and so on. And at the beginning, it was really hard to get the sensors on a scale so small, energy efficient, that they can be integrated into a tag like this and still provide accurate data. But especially through other platforms, Argo floats and gliders, there are more and more manufacturers that can provide these sensors. The data is often provided as vertical profiles because we oceanographers can easily cope with that. But they can also provide time depth profiles, more like a glider. The sensors are usually calibrated because their purpose is to provide oceanographic data. And over the last 10 years, different groups have developed delayed mode quality control procedures and pretty much copied from the Argo community how to provide the data, what's done to the delayed mode procedures, and how to deliver the data. It's very much copied from Argo float profiles because oceanographers are used to that and can easily then incorporate this data into their own work. One example here, I use this because that's built in-house here, is the CTD satellite relay data logger. It's roughly the size of your fist. I don't have one here at the moment, unfortunately, or out and used. And they have in the middle a little CTD that's built by Valport in the south of England, with a temperature sensor and inductive cell to provide conductivity information. There is a battery that powers the whole tag, a little computer inside, PC interface, also Bluetooth nowadays, and an antenna to provide this data in near real time to the Argos satellite system. The lifetime at the moment is about 11 months. And that's a trade-off between providing a lot of data, but also we can't extend that because animals molt once a year. So when you glue this tag to the fur of an animal, it will drop off after about 11 months. So there's no need to extend the lifetime, really. Because we are so limited by Argos to send data, really. Only about 70 to 20 depth points with temperature and salinity or fluorescence are sent per vertical profile, and about 4 profiles a day are sent, or the tag tries to send them every day. The accuracy is about 30 millikelvin in temperature, 0.05 in salinity. It really depends on the delayed mode quality control. Again, Argo floats have the same problems, but these tags very often work in polar oceans where the quality control is even worse. You need the right reference data. But there are several people working on that. Also, Fabian Roquet did a lot of work on that to calibrate these tags. Pictures tell you more than 1,000 words. Here's a little movie. So when you tag these animals, seals, as I said, work very well because they have a fur, they come ashore, and you can catch them and put a tag on them. And then the seals will go out to sea and do what they do. They will dive. And during the dive, the tag will record just pressure and time every couple of seconds or so to get what's called this time depth recording, time depth profile, which is so useful for the biologist to infer different kinds of behavior. When the tag realizes the seal is coming back to the surface, like an Argo float, the tag will record temperature, salinity, and all the other sensors every second or so on the way up to the surface. Because the throughput through Argos is so limited, you can't send this high resolution data. So this data has to be reduced within the tag before it's sent, and that's done by choosing what are called these inflection points or broken stick points. And I think XBTs did something very, very similar. So you just send the most important points back to the shore station so that you can recreate the profile. And then this data is compressed into these Argos messages and sent via the Argos satellite system to a shore station. Argos really works globally, so this is something that's used on a lot of tags to provide the capability to get information from wherever you are on the globe. Some other tags use mobile phone technology. Again, that only works then when you are close to a shore with mobile phone coverage to get the data back. One really important thing, before I forget, this is why I put this slide in, is that here this platform is alive. So all the work I will show to you and future work that will happen deals with animals and has to go through ethical approval. That's something everybody here has to have in mind. So we can't just use animals. You always have to look into the ethics. What does the animal gain from being tagged? So the next section is about the history of animal-borne instruments in observing the ocean, not within the observing system, but in observing the oceans, because for more than 10 years, these tags provide oceanographic data. And I will give you a couple of examples here. So the real first project that tried to provide oceanographic data was, I think, the SEOS project. There were a couple of small projects, especially in Norway, that were like proof of concept studies, but the Southern Elephant Seals as Oceanographic Samplers project, SEOS, was an international project that tagged elephant seals in the Southern Ocean and wanted to learn more about these elephant seals, but also to record oceanographic data. And that was about 2004-05, I think. And out of that developed the MEOP project, Marine Animals Exploring the Oceans Pole to Pole. And this project was a consortium of many different nations that wanted to support the International Polar Year in 2007-08. Again, as everything in observations there was no funding for that, so everybody had to bring in their own national funding to support this consortium. And the idea for the IPY, for the different projects, groups within MEOP, was to investigate the behavior and well-being of marine mammals, especially in both poles. And I think for the first time really written down in the project was also the provision of oceanographic data to the wider community. So I think that was a real first project that wanted not only to work with these animals, to learn more about these animals, more about their ecology, how they fit into the ecosystem, but also to provide oceanographic data to other people that are not within MEOP. During the IPY, MEOP became one of the largest oceanographic data providers from the sea ice zone, which I think everybody found really, really exciting. The people within MEOP, but also the users at the end. MEOP didn't stop after the IPY. It's still used as an umbrella name, a brand of a lot of tagging studies around our planet. So it's still alive, and MEOP data has produced more than 103 publications within biology, ecology, but also within oceanography. And an example of the data is on this slide. So this is the MEOP data, and there was an excellent community paper by Anne Treasure showing the MEOP data collected since about 2006 or so. There are more than 500,000 profiles within the database from about 1,200 tags. And the world map and the polar views on the right really show that the data is collected in the polar oceans and in the shelf seas, in the sea ice zone. And I find that really, really exciting. It's a fantastic complementary data set to Argo floats, ships, gliders. Just provides a different temporal and spatial resolution to bigger observational strategies. All this data is freely available. It went through delayed mode quality control. Fabian Roquet did a fantastic job in providing this data on the MEOP website, and you find the link here on the slide. You have to register, and then you can download the data. And at the bottom left figure, you also see by latitude the number of profiles compared to the World Ocean Database, and in blue you see these data from the animal-borne instruments. These comparisons are, you have to be a bit careful. We only have 16, 17 depth points and not like a CTD 5000 or something. But it just indicates that these tags can provide and contribute to the ocean observing system in specific regions. Roughly at the same time, like CIOS and MEOP, there was a big program in the Pacific run mainly by the US, the tagging of Pacific predators, really spearheaded by Barbara Block and Dan Costa. And this group tagged a wide range of marine animals. And the focus here was not on providing environmental information, but looking at different species, how they interact with the environmental landscape habitat. So really look at the ecosystem as a whole. But some of these animals were tagged with instruments that recorded temperature data, for example, birds, also seals, and so on. And out of TOP then developed, I think it's now called GTOP, Global Tagging of Pacific Predators. You can also go to the website. I provided the link here, where you can look at all these tracking studies, where these animals go nearly in real time. And I'm coming back to that a little bit later. Now, 2, 3 very specific examples. Go to the MEOP webpage, look at the publication list. There are plenty of examples of how this data can be used. Just want to highlight a few where I think they really bring home a certain point. So this is data from the iStar project that looked at the area in front of the Pine Island Glacier in Antarctica. And here about 14 seals were tagged, Weddell seals and elephant seals. And over the winter, roughly from March to November, more than 8,000 CTD profiles were collected. And on the right side, you see 2 maps showing potential temperature at a certain depth. And on the top one, you see data from the CTD database and Argo database. So this is temperature. And below, you see the data collected by the seals. And I think this is a really nice example that brings home the advantages, opportunities by using animal-borne instruments, by creating a really nice temporal and spatial resolution. So in conjunction with gliders and moorings, you really provide a bigger view in an area. And from the more traditional measurements on top, it's really hard to see where the so-called warm water, modified circumpolar deep water comes onto the shelf, while from the seal data, you really clearly see the inflow of this warmish 0 degree, warmish water towards the Pine Island Glacier, and how that impacts then the melt of the Pine Island Glacier and so on. So here really it's, again, this complementary data, working together with ice tether profiles and ships that provide high resolution, accurate point measurements that can be used for quality control. You have Argo floats, especially in the open ocean, and the animal-borne instruments really fill in time and space. The other thing I have to mention is that animals very often work as what we call adaptive samplers. So if the ocean is boring, so very homogeneous, then these animals will often travel quite fast through it, because it also often means there's not a lot of food available. While when you come to fronts, gradients, eddies, which are also often associated with prey, these animals slow down because they start to feed and provide a higher temporal and spatial resolution in areas where you have a higher oceanographic gradient. So it's kind of what we call an adaptive sampler, and it works very, very well. Another example here, I don't know if Fiona listens in, that's work we do here in the UK with the UK Met Office, started last year for the first time, where new tags were developed that provide the standard behavioral information. The whole project, the tagging is done for a behavioral study, but the Met Office provided an Argos PTT to get data in real time and doesn't have to wait for the animal to come back closer to the shore for mobile phone coverage. And in this project, more than 6,000 temperature profiles were collected over the last summer by 19 gray seals. And the map at the bottom left shows you the locations of each temperature profile. All the data was sent or tried to be sent within 48 hours. So that's near real-time data. And this data was then assimilated into the Met Office Global Ocean and the Northwest Shelf model on an operational basis. And you see the difference to what I showed you before is really that this is data from the shelf region around the UK within, I think, 200-meter water depth, which is, I think, also one of the first projects doing this to provide oceanographic data from the shelf, European shelf, to the modelers. And the bottom right plot shows you the data coverage over the different months over last summer. So the peak was really within June, July, August, and then September. And then there was a drop-off because a lot of animals come then in to breed. And I think this project also will go on this year as well. Then more directly, how this data can support the modeling community. Again, there are many papers that looked into that. There's a fantastic paper again by Fabian Roquet using the eco model. This is work done by Fiona Cars, spearheaded at the Met Office, where they used different models from the UK Met Office global foam system by assimilating the animal-borne instrument data from the Southern Ocean or not, and comparing the outcomes. And the two main outcomes here were that the ocean fronts were much more defined, sharply defined, and extended deeper into the ocean. So that's a top plot here, than if you would not include the seal data. Personally, more exciting, I think, was the second point, that the effect of integrating this data extended beyond where the data was collected. Obviously, that has nothing to do with that the data was collected by seals, but it just shows how important data from under the ice is to get your modeling right, and how that affects the bigger ocean, the global ocean. It's really important to get this data from under the sea ice. A little bit more towards the biology now, that the data can also provide information on the ecosystem. Here's an example from Norway, from Svalbard, run by the North Polar Institute. They tag ring seals for many, many years. And here the study showed that there was a dramatic shift in the behavior of ringed seals. In yellow, what you see are tracks recorded around 2002, 2003. And the white line shows you the sea ice extent in these years. A couple of years later, there was a big change, and the sea ice now moves in the summer further north. And the seals tagged after this environmental change totally. So in red, these ring seals, you see, travel further north and just further, longer trips. And this study showed that these animals have to change their behavior because the environment changed. They have to dive longer, they can't spend so much time at the surface, which means if you look at their energy budget, that changed. They have to put in more effort to get their food. So you can use this data also to look at ecosystem changes. So do we need animal-borne instruments in the global ocean observing system? Obviously, I think we do. I think animal-borne instruments can address all three major themes within the global ocean observing system. And I chose the examples to address this, obviously. So for climate, they can provide essential data from the sea ice zone and also from the winter. And that can really extend the spatial and temporal coverage from any observational strategy we have in the polar oceans especially. That's, I think, really, really exciting. And a colleague of mine said that if you do polar research, if you don't use animal-borne instruments, you're stupid. His opinion, I'm quiet. Also, animal-borne instruments can provide real-time data. Again, that's something I find very exciting. You don't have to catch these animals. Within a couple of hours, you have temperature salinity profiles from the Ronny ice shelf in the middle of the winter. So that's fantastic data that you can use for your oceanographic projects, but also this data can then be used in environmental models and forecasts. And then also, as I've shown, these tags can give information about sentinel species, top predators within an ecosystem. And that's a very direct way to monitor ecosystems. So it's can really provide information on ocean health, one of the three themes within the global ocean observing system. So if we look at the different themes and ocean variables or panels or whatever within Goose, I stole this little slide, I think, from somebody from Goose. And I put in little tagged sea lines to show where animal-borne instruments can really shine. And in black, I think these are the strongest impacts. And obviously, within biology, data from these tags can provide a lot of information addressing everything from climate, real-time services to ocean health. Within physics, the data can absolutely address the real-time services. With climate, it's in gray, and same with ocean health. I think the data is very, very useful, especially when it's used in conjunction with other observational strategies, other platforms. It can just provide the right temporal and spatial resolution to really make your observational strategy shine. In biogeochemistry, it's gray, light gray. It really depends on the sensors on these tags. A lot of these sensors, I think, are not there yet to be deployed for a long time without the chance of getting them back and recalibrating them. So how useful this data is for biogeochemistry, I think we have to show. But I have hope that especially with glider deployments and Argo float deployments, new sensors are being developed that can live on a marine animal for a long time and provide accurate data. So coming to the current networks, how do we integrate all this into Goose? There are major groups, say, that work with this kind of data. There's an ocean tracking network, and they aim really to use aquatic tracking and external environmental data to support a sustainable management of aquatic species. So this is really about tracking fish and other animals in the marine environment. But some of these tags also record environmental data that will be made available to the wider community. MEOP, I already talked about MEOP, is again not funded directly. It's a brand, a name that brings together different national programs, small groups that can work within the expertise that MEOP generated. And there's a data portal where you can download the data. And there are plenty of other small research groups, especially in Europe, that are not part of any of these, that still generate tracking data and also environmental data. And that's a resource nobody really tapped into yet. But animal-borne instruments more recently are really part of regional ocean observing systems. So if you look at this figure, we have 3 RUSes that have animal-borne instruments within their observational strategy. That's Eurogoose here and also Moongoose in Europe. We have Imus, we have US, the Integrated Ocean Observing System, IOS, and also SUS. And all these groups have kind of task teams that deal with animal-borne instruments. And then very briefly only go and give you a couple of information about these different RUSes or task teams. So in Australia, we have Imus, the Integrated Marine Observing System. It's funded by the Australian government and has an open data policy. And Imus has a group of people that integrate animal-borne instrument data as well as tracking data into Imus. Has very close links to MEOP and OTN. It's also hosting a lot of the data. And Xavier Henao, Rob Harcourt, Mark Hindell, Clive McMahon, there are a lot of people that really work hard to bring this data to the wider community, archive it, and make it available. And by the way, at the bottom, this is a plot I just made this morning on their data website from Imus. It's the Open Access to Ocean Data, Australian Ocean Data Network web page. You can go in there, you click a couple of click boxes, and it will show you the animal-borne instrument data that's available within Imus. Then we have the animal telemetry network within the US IUs. Again, it integrates, which means it manages data, it hosts the data from animal-borne instruments, also tracking data, behavioral data, and physiological data. And again, has very close links to MEOP and OTN, but it's within a proper RUS. And again, the figures I showed down here are taken this morning from their data portal. So you can go onto this map, click one of these little dots, and it will show you the data. I think this is a sea line and where the sea line was during the last couple of months. So it's real-time data. It's very accessible. Very often you can download the data, or you get the link to the contact to the PI to get the data, whatever you want. It's tracking oceanographic data and so on. Within Europe, we have the animal-borne instrument task team. Again, this integrates data, MEOP data, but also data from the shelf. I showed you the data with the Met Office on the EMODnet physics portal, which is one of the portals from Eurogoose. And at the moment starts to expand and include other kind of tracking data, not only the oceanographic data, so fish data and so on, behavior and physiological data. And again, very close links to MEOP. SUS has no real task teams, but animal-borne instruments were involved in different reports or task teams that provided reports within the Southern Ocean Observing System. And I think I showed you how this data can really help to provide a really nice polar observational strategy, in this case, Southern Polar Strategy. So coming to the data management, I think that's a whole day, a workshop to talk about this. But over the last 10 years, there were a couple of best practices and standards developed for the environmental data, for the oceanographic data. So very much following Argo floats. There are two data streams, the near real-time data where the data comes, for example, through the Argos system, is then decoded and broadcasted on the global telecommunication system, where users can get it and use it, especially in the operational modeling community. And we have the delayed mode data stream, where the data goes to the PIs. They have to do delayed mode quality control with the help of the community, and then provide this data on these data portals. All this very much followed Argo floats, and therefore focuses on the open ocean. Within Europe, we are currently working on providing standards for data from the shelf, which is a little bit more difficult to provide a good quality control. Then we have biological data, and that's a bit more, tricky. There are groups, especially the animal telemetry network and ocean tracking network, groups that work on providing biology or ecosystem data to the ocean observing system, tracks or physiological information. And that's, I think, still in the beginning, and it's really not easy to provide this data because there are so many different formats how this data can be provided. But there are groups that try to standardize this data. There's an IUS Animal Acoustic Telemetry Data Project. There's a lot of work together with Imus, and there's also the International Biologging Society that started a working group on data standards within the biologging work. And I think this is something that we have to do to look at standardizing the data to provide information on ocean health. So what's the future of animal-borne instruments? Well, I think we have to keep the momentum. It's nothing new. For 10 years, tags provide data to the ocean observing system. More recently, they provide more biological information. We have to use the regional and project-based expertise that is available now to create a network within GOOS, I think. So these people are already included in expert panels. They are part of RUSES, these regional alliances, which is really good. And just recently, last year, there's a group, and we are part of the OCG from JCOMS. So there is like a task team created to look for this network and the operational coordination on a global basis. But this really has to go forward to provide advice to all these different groups on our planet that still do animal tagging. There are a couple of white papers that are in the making, and two big ones, I think. One is on people have to sit down and think about a network design and really define the role of animal-borne instruments in this multi-platform mix we have within GOOS, and have to provide information on agreed practices. I think my personal opinion is not to provide one way to do it. People have different strategies, and it depends on the fund as well, but at least agreed practices and point to white papers that describe how these practices work. And obviously, we also need some input from GOOS, so the other way around. So what are the requirements? How can we address requirements that are still open within GOOS? We focus already on the oceanographic data, so this seems to work, but we now have to get biology and ecosystem observations into GOOS. So we have tracking data, we have behavioral information, and all these can provide a unique data source, really, to address across GOOS themes and panels. So one platform addressing different things, and I think that's exciting. But that means we have to provide guidance on this kind of data, so everybody can use it. At the moment, we follow already the integration of other platforms. Gliders is a typical example. So we're a little bit behind them, how we are integrated in GOOS, but I think it's a nice example, and we are just following this example. Really important is that we have to support interdisciplinary projects to create a sustained way of getting deployments. It's a win-win situation. If you work in the same area, biologists and oceanographers, sometimes the oceanographers get the funding, sometimes the biologists get the funding. So because you address different research topics, but you provide the same kind of data at the end, I think it's a very good way to provide sustained data from one area. So one idea we have at the moment is to create a steering team under JCOMS that provides the data and expertise to goose physics and biology, and under that have 2 working groups dealing with environmental data and one more with the biological data or ecosystem data that can provide information on ocean health, especially because there's really totally different expertise involved based on the nature of this platform. So concluding, animal-borne instruments are already part of GOOSE, especially within the regional ones. Animal-borne instrument data, tracking data, can really address different themes and panels at the same time. So it's quite unique as a platform, I think. Animal-borne instruments can provide a win-win funding situation, so there are different funding streams available to work in the same area, but by addressing different research questions. And that will help to provide sustained observations. There's already a large pool of expertise out there by providing environmental data for more than 10 years and by collecting behavioral data for more than 50 years. And that we are at the point where we have to create something like a global task team. And then, yeah, it's not me alone. I'm just a messenger. There are so many people involved in all this work. So many different funders, and I just try to put a few of them on this slide. And I'm ending now. Thank you very much for listening.
Thank you very much, Lars. That was a really great and thoughtful and thorough talk. And as I was jotting down questions, you often answered them a few slides later. So let me open the audience, the questions to the audience. Please type them in the question box and press on the Send to All button. And I'll kick off with a few questions of my own. So Lars, thanks a lot for addressing the ethics question. Obviously, one of the huge differences between the work that you're showing here and all of the other parts of Goose is that the platform itself is alive. And so there's a lot of questions about how the animals react to being tagged. Does it affect their behavior? How do you know that? Can you tell us a little bit more about the review process that you mentioned, about how do you review from an ethical perspective what the animal gains from being tagged?
So all these projects have to go through ethical review. The real process depends on the country, on the university, on in which environment you work. But essentially, it comes down to very basic questions. You have to minimize the impact. You have to try not to be invasive. Is it necessary to tag an animal? So there are very basic ethical questions, like work with humans as well, that you have to answer sufficiently to get the permits to tag an animal. Over the recent years, I think that all the projects that used animal-borne instruments were mainly driven by a biological question. So there was always a reason to tag these animals. There was very often a second one, which is we collect data and provide it to Goose. But we were not using animals to gain data access to a certain region or anything like that. The beauty is the more we learn about the environment, the more we learn about animals. So as I said, it's a really nice win-win situation that when we learn more about the environment by collecting data, by providing this data to a modeling community. They provide the wider picture. We can look at ecosystem change, global change, climate change, link that back to the well-being management and conservation of these animals. So that's a really important point we have to make. Obviously, when you catch an animal, you stress them, and you have to minimize that. So people have to be trained to catch animals and tag them. Are animals affected by these tags? There are a couple of studies that use information from these tags to look at their well-being. Are they gaining mass and so on? So we learn that a lot of these animals are not really affected by having a tag. There are a couple of papers you can look up that show that there is not, at least put it that way, within the error bars, we can't see a negative or even positive impact on these animals by tagging them. And the manufacturers are all really trying to make them as small and light as possible.
All right, thanks a lot, Lars. Just a follow-up question in that respect. You know, you emphasize that all of these projects have had a dual nature and have been primarily driven by interest in the understanding the environments of the animals and ultimately in managing that environment and managing the human relationship with them. Do you see that there's scope for, in the future, these types of animal-borne instrumentation programs being funded in the context of regulatory regimes where we're trying to manage the environment, manage the well-being of the animals?
I think it can be part of it. I don't think it can be a primary driver, because then again you would use an animal, tag an animal to get information about the status of an MPA or so. So you have to show that you can't do it in any other way. But in the wider picture, I think there is absolutely scope to get funding to at least support conservation and management. And we had a couple of recent discussions, for example, to look at MPAs in the Southern Ocean, and can this tagging data help us to understand these MPAs? Are they at the right place? How are they changing with time?
Yeah, and the reason I ask is with a long-term perspective, if we would like this type of measurement to be part of a sustained observing system, we'll have to think also about what the sustained reasoning behind taking those measurements is, always with the particular perspective of the animals in this case.
Yeah. As I said, one example is you are tagging very often sentinel species, so they can deliver a lot of information on a whole ecosystem.
So let's jump into some of the questions that are being asked, and let's start with one that are related to the technology. So you talked quite a bit about the limitations of sending the messages through Argos and having to reduce the amount of information that's sent just to the sort of important inflection points. Wei-Young Yu has a question about whether Iridium satellite communication can be used for full higher density profile data. And as a follow-up question is how far can the animals swim beneath the ice shelf? And do we have any efficient tools to measure or even know if they swim into the shelf, since we don't have position information?
So to start with telemetry, which is one of the big constraints. Obviously, when you have mobile phones, it's fine. Out in the open ocean on a global basis, Argos is kind of the only way at the moment. The issue is that these animals come only to the surface for about 3 minutes. So you can't have any telemetry network that needs, for example, a handshake. So Argos is so well suited because you just send out your data and hopefully it's received. You don't have to listen for anything. Two-way Argos obviously could help, so you don't have to send information a couple of times, because that's what these tags do, because they don't know if data was received. The same data is sent a couple of times to increase the possibility for the receiver to listen and record the information. Iridium, again, could be something for certain species. I'm looking, for example, into weddell seals, and they hole out on the ice once in a while. So they spend more time at the surface, and there something like Iridium could work to send more data and also have a two-way data transfer, so you can switch on and off certain sensors. I'm really interested in that. Getting data from under the ice shelves. I don't think animals swim under the ice shelf. They swim under the ice, the sea ice. And there, the position is obviously only recorded when these animals come to the surface, which means that if they swim under the ice and come up here, the data is still from here, but this is our surface position. And normally then, we interpolate over time from these locations to associate a position with your measurements. Linearly, that's all we can do. But normally, you get plenty of locations within a couple of kilometers, so the error is not so big, even if you look at mesoscale or smaller scale features in the ocean. I don't think any animals go really under the ice shelves, unfortunately, although there apparently is food. Maybe they go, but we never see that because they can't come up on the other side. They always come back in front of the ice shelf.
Have there been any programs where you use underwater acoustic transmitters to try to geolocalize the animals underwater? So
there are a lot of in history programs, but also, for example, now OTN programs that use passive monitoring, or others use active monitoring using sound to localize animals underwater. You can also use, if you have a tag that can record archive data and you get it back, record accelerometry data, so you can create three-dimensional dives underwater and can associate them with the surface locations. On large scales in polar oceans, I don't think that has been done. Unfortunately, because of different constraints. People say you can use the sound sources that are out there for Argo floats and so on. But again, that's so much data you would need to send back from these tags through Argos. It doesn't work, unfortunately, at the moment.
Are there some technological solutions to that telecommunications problem coming on down the line?
Well, there's Argos two-way. Which would help to minimize the data you have to send twice or three times. Mobile phone coverage. So there is a little bit of hope for these low orbiting satellites for mobile phones. If this works, then I hope it's a little bit like Iridium, but hopefully faster because it's mass produced really in large quantities. Something that could be used in tags. But that's like I would say, 10-year thing, hopefully, or longer.
So let me ask a question from Rolly Rogers. He's asking, what work has been undertaken under the applicability of Part 13 of the UN Convention on the Law of the Sea to animals instrumented that enter the coastal waters of another state? How do you deal with the fact that you're not directing the animals? They're certainly not aware of national borders. How do research programs deal with data coming from national waters?
So it's, again, very similar to Argo floats. You can't really predict where Argo floats go. So you have to inform through your projects, the appropriate people. Very often, interestingly enough, I didn't show a plot, you can predict where these animals go. So there is a way to anticipate your data collection. If you know specific animals, you know pretty much exactly where they go. If you take new animals, depending on the species, their life history, you have an idea in which areas they go, and you can contact the appropriate countries. Obviously, there are some countries that very clearly state that you can't collect any data in their coastal waters, and then you obviously don't tag animals there. You try not to tag animals that go in these places, or the data has to be destroyed.
Thanks, Lars. So John had a question about, I noticed that you said that the tags, for example, only measure the physical parameters on the way up, like an Argo float. I suppose that's to have better sampling. His question is about the tags actually sitting within the boundary layer of the flow around the animal, and is there any estimate of the impact of making measurements on a warm-blooded animal in its boundary layer?
So, very interesting question. There is a recent project that was funded for a totally different reason, but with a PhD student here who looked at the drag of these tags and worked with hydrodynamic modelers who are building ships, I think, to create models and looking at the flow. One of the results was that the flow is fast enough that the self-heating properties of the tag or the animal won't heat up the water, for example, to change the temperature measurement. The other thing you have to have in mind is that these animals are made for swimming in the water. They are made to not, if they're warm-blooded, not to lose energy heat to the water. So they're very, very well insulated. So the self-heating effect from these animals into the surrounding water is very small. Obviously, when they're not swimming, you will see an effect. But this is one reason why we try to record the data when they swim. A couple of people still think that the animals, the closeness of the animal to the sensors can have an impact, and are still looking into how to improve the data, correct the data. It's all part of the quality control at the end.
Thanks, Lars. And we're close to out of time, but let me just ask a last question. Your last slide here shows really the huge range of activity in this area. And how hopeful are you that you're really going to be able to come to some common work on global approaches and standards and best practices in the area of both observations and in the data systems?
That says everything. I think from also, again, from the beauty is that so many different platforms pave the way. And the consensus is, I think, that there is not one way. So in terms of practices, there can be different practices. It's science, after all. People have different opinion. And as long as you provide the papers, the information, that this practice is the best way, then we can have different standards and different practices, as long as you tell people what it is. We also come to a point where we say we shouldn't have one data portal or one data collection point. We can have different places. They don't have to have exactly the same kind of standard for their data. But as long as they provide the information necessary to find the data and put it on your data portal, that's a very good way forward. Because it depends on funders and where you are. And yeah, no, I think there's not one right way.
Is there some agreement, at least on the sort of level of detail or the specifications of the metadata that should be provided with data?
So for the oceanographic data, it's very much, again, a lot of things already set in stone by GOOS about essential ocean variables, what's needed to provide with your data file, which kind of metadata, what kind of resolution, you need the error bars, and so on. For the behavioral data, that's very, very tricky. One example is if you have an animal that dives, how do you define a dive? What's a dive? And then you have 50,000 different ideas. But there are some relatively easy definitions that can be across species and help to define what's a dive in terms of behavior. And as I said, there are a couple of groups that really work hard to find a consensus on that.
All right, thanks, Lars. And I'll close with a comment from Wei-Dong Yu, who's a co-chair of the sponsors committee of the OceanObs 19 conference coming up in September 2019. He encourages this community to write a white paper to help coordinate the global and regional initiatives towards incorporation into GOOS. So I would encourage that as well. And thank you very much, Lars, for taking the time to really give this great talk and answer the questions.
Thank you very much.
To the audience, our next webinar is in 1 month's time, April 19th, and it's coming from the Copernicus Marine Environmental Service. Thank you. Bye, Lars.
Bye-bye.